We're going to talk about the standard position angles. Standard. Now, if you notice the graph is broken down to 4 pieces, we call them quadrant. So this is the first quadrant. This is the second quadrant. This is the third quadrant. And the last one is the fourth quadrant. Again, we always give them Greek letters, so the first quadrant is I. I stands for 1. This is 2. This is the third quadrant. And IV is 4th. That's the fourth quadrant. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. You'll never see them write 1, 2, 3, 4. They'll never do that. They're always going to use these. So when you have an angle, we'll see which quadrant the angle happens to be, and we'll go from there. So let me take a couple of angles, triangles here, I'm going to talk about similar triangles. I might give you 2 triangles, and I said these triangles are similar, and I'll explain what that means when I say similar triangles. Let's say we have this triangle, and I'll give you one, maybe bigger or smaller, depends how I feel. If I said to you these triangles are similar, it's like you taking this picture on a piece of paper, you go into the copy machine, the photocopier, shrink the size, for example, 60%, and make a picture of it. You end up with the same triangle, but smaller. So when you hear the word similar triangles, what does that mean? That means 2 things here. That means the corresponding angles are equal. So for example, if these are a similar triangle, if this is 30 degrees, guess what this angle is? 30 degrees. If this is 50, guess what this angle is? 50. Well, my picture is deceiving here because they have to add up to what? 180. So this is, let's make this a 70, not instead of the top one is 70. Sometimes I don't think about the stuff I'm saying. If it's 70, 50, that's what, 120 combined? So that leaves this one to be what? 60, because they have to add up at 180. So the angles have to be equal. The corresponding angles are equal. And the other one, the corresponding sides are proportional. are proportional. Let me call the big triangle, give the angle some name. This is angle B, C, and D. Or A, B, and C. I don't know, what was I thinking? A, B, and C. And I'm going to call this C, D, and E for the little one. A, B, C for the first one, and C, D, E the other one. We said the side have to be proportional. What does that mean? The ratio, or the length of this side to this. If I measure the ratio of A to B, or AB, this side to this side, it should be the same as the ratio of this side to this side, which should also be the same as the ratio of this side to that side. That's what proportional means. If you measure the length of this side to this, should be the same as this to this, should be the same as this to that, ratio-wise. Now let's take an example. We'll have fun with it. We'll see if that works out. Somebody pick an angle in the first quadrant. That means less than 90 degrees. Pick any number. Less than 90. Go ahead. 40? Okay. Let's all draw a 40-degree angle. 40 degrees right here. You can make the length of that as long as you want to. You choose how long you want to make it. Make it as long as you want to. Now be reasonable, don't go crazy with it. Now let's make this, draw a 90-degree angle down, and there's my triangle. Now go anywhere inside that and draw another line parallel to the one we did up there. Now we have similar triangle. We have the big triangle and the little triangles are similar. If this is 40, this is 90, I know what that angle is. What's 40 and 90? 120? That's really 60. What's this angle? That's also 60. So the angles have to be the same. Well, they are the same. The corresponding angles are the same. With the big triangle, if I do the big one versus the little one. Here's my big triangle. This is 40 for both of them. This is 90 for both of them. That little right triangle means 90. Can't be 60 here. It must be 50, right? 50, not 60. That should have been a 50, not a 60 here. 60 and 40 and 90, 190. They have to add up to 180. And if we did it correctly, let's measure the length of them. Take a ruler now, which I gave you one, and let's measure the ratio of the side. Let's look at the big side here. We'll use millimeters. That's the closest, I mean centimeters here. I'm going to measure the length of this one. I wish I can see what that number is. I can't tell if it's 5, 6, 7, or 8. So notice the bigger side going up, I'll go 5.7. Measure the length of it. Let me measure the length of this side. That looks like 7, the big triangle. Let me measure the length of this side. Eight, 5, 6, 7, 7 or 8, I can't tell. 8.7, I'll say. It might be 8 actually. 7, 8, somewhere in that neighborhood. Let's take the little triangle. We'll see if these sides are proportional, the length of them. The height for the little one is what? It looks like 3.5. The bottom side for the little guy, I think 4.3. 4.2, 4.3, somewhere in that neighborhood. And the length of this, the little side, that's 5, 1, 2, 3, 5.3. From this point to that point. Now we're saying the angles must be equal. They are equal. And the ratio of the side should be equal. We should be very close to that. So if I take this side for the big triangle to this side, the 5.7 to 3.5, that ratio should be very close to this side, which should be the same as this side, which is 8.7, to that side, which is 5.3. The length of this to the length of that should be the same as this to this, the same as this to that. Let me divide them on my calculator and see if I'm close enough. This side is 1.6286 roughly. What's the other side? 7 divided by 4.3. 1.6279. And the other side, 8.7 divided by 5.3, 1.642 or 15. Again, if my eyes were good and I can read, is it 0.2 or 0.3, these numbers will be exactly the same. That ratio has to be the same. You heard me saying I can't tell if it's 2 or 3, it's in between them. So you put a 2 versus a 3 is going to change your answer. Just to show you, if I made this one instead of 3.5, 3.6. Or if I made that 5.6 instead of 5.7. Just one change. If I made that a 6 here, what's 5.6 over 3 this one? The last one. What's 8.6 divided by 5.3? 1.6226. It changes that answer. 1 millimeter off there. It put me in a different neighborhood. This actually where, Tom, we're talking about the degrees, if you want accuracy. Just like if I measure the length of this, I'm in between the 2 and the 3. I don't know what that number, depends which one I use. I could have 1.64, I could have 1.62, based on which number I chose. I don't know what the length is. It's between 2 and 3. Which one you want to use? If I have a better way to measure this, and there are better ways to measure these, we have devices that will read them much accurate than this, actually a digital device. And we can measure that and tell you what that number is. You'll see these numbers will be exactly on the money there. But that's what similar triangles are. They have the same look, they look like the same shape, the angles are equal, and the ratios of the sides are the same. I think I told you the story when I took that STEM class last semester. The first time they came in here, and I want them to think, and I said, we're going to measure how tall the tree is. And what we did out there, we have these tall trees. They look like this. The first tree. And I said, I want you to tell me how tall the tree is without climbing it. And it was a beautiful sunny day. Somebody said, measure the shadow quickly when I was talking to the class. There's your shadow, okay. The shadow is 15 feet. How is that going to help me? How tall is the tree? What's the height of the tree? I know the shadow is 15, big deal. What's the height? Someone said, make a triangle. So there's my triangle. Still not helping me. So my triangle for that tree there looks like this. I'll make it bigger now. That's my triangle for the tree. All I know, this is 15 feet, the shadow. That's all I know. That's it. I can't climb the tree, and I don't know what the length of that side. How am I going to figure out how tall the tree is? Shadow of the person. Yes, I took the person there. I said, stand here. And the person has a shadow. And we measure the length of the shadow. That's my other triangle now. You ask any person, how tall are you? They know their height. They go, okay, what's your height? I'm 6 feet tall. Okay, 6 feet. And your shadow here is 2 feet. If we do them at the same time, like within minutes from each other, you have similar triangles. And you can do the ratio of the height to the shadow should be the same as the height to the shadow. The height is h, the shadow is 15, should equal the height of the person, which is 6, to its shadow, which is 2. You can cross multiply. 2h equals 6 times 15. 60 and 30, what's 60, 90 here? What's h equal to? 45 feet. No climbing a tree, no killing anyone. You can chop the tree, lay it on the ground, measure it, then stick it back up there. It's not going to work. But that's, we can use similar triangle to figure out, you know, the height of a tree. Okay. Well, this is not that important in this section. I'm spending too much time again on it, but I just want to make sure you know it. But what's important are what's coming next, which is the basic 6 trig functions. So let's take an angle in the first quadrant. And again, I'm going to graph this because I want to show you if I'm right or not. Again, somebody pick an angle between 0 and 90 degrees. Any number you want to. Doesn't have to be a nice number. like a whole number. Well, when a whole number. 67, okay. $67. Somewhere in that neighborhood, again, I really can't see. Somewhere there is the 67 degree. So I'm just going to draw a line going through it. The length of the line is not important. At least for now. And I'm going to make a triangle out of it. Remember, this is the angle we call theta, Greek letter, and it just happens to be 67 degrees. We have three sides here. We have two sides touching the angle, one is not touching the angle. The one that's not touching the angle has a name. It's called what? The opposite. I use OPP for opposite. The two sides are touching the angle. The longer side is known as the hypotenuse, H, Y, P. And the other side is known as the adjacent. A lot of books will use Y for this because that's in the Y direction. They use X for this, and they use R for the radius because that's a portion of a circle. They use R for this, the hypotenuse. Some of you probably heard the saying, what is it? Yep. Wait, I never heard that. Sakatoa. They claim that's like an Indian chief. I know it's going to pay him. But we just have some old hippies.
Yeah.
Cut.
Some old hippie caught another hippie
Tripping on acid? Oh my goodness. Never heard that before. Some old hippie caught another hippie tripping on acid. Well, if that makes sense to you, memorize it that way. I never heard that before. I can't really use it because it talks about drugs in classroom. We try to say this is not good for you, so I'll skip it. I don't know what school Autumn went to. We won't even ask him. Some old hippie caught another hippie tripping on acid. It probably will make sense to most of the students. They might remember it better than Sakatoa. You know? What Sakatoa stands for, it says the sine of the angle. We use SIN for sine, but it's really pronounced sine of theta. Not sine times theta, sine of theta. So sine, we write sine theta equals. Notice sine, O for opposite, H for hypotenuse. So it's the opposite over the hypotenuse. The opposite is Y, hypotenuse is R. The next one, the cosine of theta. And we write that cosine theta Doesn't matter if you use parentheses or not. Sometimes I put parentheses for the angle, and sometimes I don't put them. I'm not sure why I do that, but it really doesn't matter. Ka. C for cosine. Ka is what? Adjacent over the hypotenuse. So that's what? X over R. The next one is the tangent of theta. The tangent, we use tan theta. And tangent, according to Sakatoa there, opposite over adjacent. Opposite is what? Y. Adjacent is X. Now, there's 3 more here I'm going to be adding to that list. If you look at any calculator, you will see sine, cosine, and tangent. Sine, cosine, and tangent. You can see them here. But you will not see the other 3 trig functions I'm going to mention shortly. And that's secant, cosecant, cotangent. What's the secant of theta? And again, that's the secant of theta. It's actually 1 over the cosine of theta. So if you know what your cosine is, flip the answer. What's the cosine? The adjacent over what? Hypotenuse. So when you flip that, what are you going to have? The hypotenuse over what? The adjacent. Cosecant of theta. The next one. That's cosecant theta. Cosecant is 1 over the sine of theta. Find the sine and flip it. That's the hypotenuse over the opposite, which is R over Y. This one was R over X. And the last one is the cotangent of theta. Cotangent theta, which is 1 over tangent theta. Adjacent over opposite, which is X over Y. Now, let me give you an example, see how we're going to use these. If the terminal side of an angle passes through (3, 4), the point 3, 4, find what? Question number 1, the sine of theta. Question number 2, cosine of theta. Question number 3, tangent theta. Question number 4, secant theta. Number 5, cosecant theta. And number 6, cotangent theta. All of them, all 6 trig functions. So let's see. Let me draw a picture there. Maybe it'll help us visualize what we're talking about. 3 comma 4. You're going to go 3 units in the x direction and 4 up. Somewhere there. That's 3, 4. So if you complete your triangle, you know this is 4 and that's a 3. So I can answer 2 questions. This is the angle. This is theta. Remember, Sakatoa. Let me write it down again. The sine is what? Opposite over hypotenuse. I got a problem. I don't know the hypotenuse. Cosine, ka. Adjacent over the hypotenuse. I also got a problem. The hypotenuse is in the way. Tangent, opposite over adjacent. Hey, I can solve for this. Do I know what the opposite from that picture? What's my opposite? 4. What's my adjacent? 3. Hey, I didn't get a 0. That's a promising there. You get something there. Secant. 1 over the cosine of theta. That means hypotenuse over the adjacent. Hypotenuse is getting in the way there. Cosecant, 1 over sine. Hypotenuse over the opposite. Can't do it. And what's the cotangent? 1 over tangent theta. Do we know what tangent theta is? 4 over 3, 1 over that, flip it. The reciprocal. So we get 2 out of the 6 questions correct. That's it. 2 out of 6. 1/3, 33 points, or 33%. If I know what that hypotenuse is, I'm done. If somebody can tell me what this side is, we can answer yes. How'd you get 5? Yes, Pythagorean's theorem. It says r squared equals x squared plus y squared. We used to say c squared equals a squared plus b squared. That's called Pythagorean's theorem, or Pythagorean's theorem. Now we know what x is 3. 3 squared, that's a 9. We know what y, which is 4 squared, that's 16. What's 9 plus 16? 25 is r squared. And what's r equal to? 5. So notice I solved for the hypotenuse. Now I know this is 5. I'll put it in now. Now I can answer all the questions. What's the sine? Opposite over hypotenuse, 4 over 5. What's the cosine? Adjacent over the hypotenuse, 3 over 5. What's a secant? Hypotenuse over the adjacent. This is the hypotenuse, there's the adjacent, 5/3. Or take the cosine, flip it. Cosecant, 1/sine. This is your sine. Flip it. And now I get all 6 questions correct. So first I had to use Pythagorean theorem to get what C is. And once I have C, or this side, R, whatever you want to call it, I can use the basic trig functions to answer that. Let me try one more question, then we'll call it quit. I just want to make sure you get this part. That's really the biggest piece of the trig. If you understand this, as we advance in that, will make sense. Given, changing the question a little bit, given sine theta equals 1/2, no calculator here, find cosine theta and cosecant theta. I could ask for the rest of them, actually, the rest of the trig identities. I'm drawing at just an angle here. I'm not drawing it to scale. I'm not paying attention to it. We've given you the sine to be 1/2. Remember Sakatoa. The sine is opposite over the hypotenuse. That's what the sine is. And it's equal to what? 1/2 in that problem. That tells me what? This side is 1 and this side is 2. That's your opposite. This is your hypotenuse. Can I figure the third side? Pythagorean theorem. R squared equals x squared plus y squared. This is R here. This is y. This is x. 2 squared, that's 4. X squared plus, what's 1 squared? 1. X squared equals 3. X equals what? The square root of 3. I'll do all the rest of the trig functions. Since I got all the sides, you want to find the cosine? Cosine is the adjacent over the hypotenuse. What's my adjacent? Square root of 3 over 2. Tangent. What's the tangent according to this definition? Opposite over what? Adjacent. What's the opposite? 1 over adjacent the square root of 3. One little problem here. Most math books don't want to see a square root of 3 in the bottom. You have to rationalize your answer. So to get rid of that, you multiply the top and the bottom by the square root of 3. What is 1 times the square root of 3? The square root of 3. What's the square root of 3 times the square root of 3? Just a 3. So you have to get rid of the square root in the bottom. You have to rationalize your answer. Secant. Secant is 1 over cosine theta. Find your cosine and flip it. There's your cosine. Flip it. 2 over the square root of 3. Again, we don't want to see a square root in the bottom. Multiply the top and the bottom by the square root of 3. Cosecant. So we answer one of their questions. That's the cosine. The next one is cosecant. Cosecant is 1 over sine. So you take the sine, you flip it. What's the reciprocal of 1 over 2? 2 over 1, which is just 2. Don't write 2 over 1. And I'll do the last one. The cotangent of theta. They didn't ask for it. It's 1 over the tangent of theta. There's my tangent before I rationalize it. It's this one. If you flip that, that's the square root of 3 over 1, which is the square root of 3. And that's all 6 trig functions. So by knowing one, I can figure the rest of them.